And then you fine tune. So we get to the fun part. We fine tune. And I'm going to say just a little bit on this. So someone asked about fine tuning versus instruction fine tuning. RLHF is in there. And I kind of left the slide blank to answer any questions that we had there. So I'll clarify a little bit and then put out a call for questions. But the way to think about fine tuning is that you're taking a model and you're training it and using it for some other purpose. That purpose may be more specific. It may be a particular domain, like fine tuning a model for code, maybe a particular task, like classification. It may be some other paradigm. And what tends to be popular for general purpose chatbots is a process where we start by fine tuning for anything. Fine tuning is kind of the umbrella term. And one thing we might do is what's called instruction fine tuning or supervised fine tuning, SFT or IFT. SFT is becoming more popular, so I've started switching to that. And the idea is that you have a lot of example interactions with the model, a command or an instruction, and then a response. And all you're doing is you're kind of training the model to, see its first part of its input as an instruction and then respond to it. Because naively, the model is just trained to spit out documents. It's trained to just kind of continue generating tokens. And giving it some examples of instructions and responses is really helpful. And I mentioned last time, on the order of tens of thousands, will get you into the ballpark of Llama 2 in terms of what they did, as long as they're really good quality, and quality matters. Then there's a process called RLHF, and I'm going to say a little more about RLHF. Hugging Face has this beautiful blog post on how RLHF works, and I recommend reading it, but I stole a couple figures from it. And the idea is that we can ignore the RL part. I think almost there is RL going on here, but I think it overcomplicates things in terms of understanding. All you do is you take your language model, you generate some outputs with respect to some prompts, and ask humans what they think of them. Was this good or bad? Was this one better than that one? How much better was this one than that one? And then you train a model to predict a score for each response. Like, how good was this response, or how good would humans say this response was? And then you go through this more complicated process. This is the RL part, so I'm not going to dwell too much on this. But all you do is you essentially train your model to, to maximize the reward, to give prompts that humans would give high scores to based on this reward model. You can also, you'll see this initial language model over here. You can also kind of, you don't want the model to stray too far or kind of get too, get too obedient in some sense, or kind of, try to max out the reward. So you can also constrain the model to behave like the initial language model a little bit so that it doesn't change too much. So, that's the RLHF process. And the idea with RLHF is that you're trying to get the model to align better with human preferences. When people talk about alignment, this is often the technique that they're looking to use. The last thing I'll mention is LoRA, because LoRA tends to always come up in the context of fine tuning, and I didn't want to go without mentioning it. So when you fine tune, often what happens is you're modifying the weights of the whole model. But not all of us have a big fancy GPU where we can fit all the weights in the model. And sometimes we want to have many, many different copies of the model fine-tuned for different things. This is where LoRA comes in handy. All LoRA is a way of kind of, you learn this thing on the right. You've got your pre-trained weights on the left, and you learn a modification, a delta, a change to those pre-trained weights. And that change is actually, you would typically have to have a matrix as big as the matrix representing your weights. But in LoRA, you split up that matrix, you factorize it into two kind of low rank matrices that you can multiply by each other to create one big matrix. The idea is that this does give you a way to change all the parameters in the pre-trained weights, but it takes up a lot less memory because you don't have a full additional copy of that matrix, just two much smaller tensors. So it's lower rank. It doesn't allow you to change, it gives you a limited basis on which to change the weights, but LoRA tends to work really well in practice. And so it tends to be pretty popular, especially if you're at home and you have a 3080 or, some older GPU that doesn't have as much memory, or just a gaming GPU in general. LoRA tends to be a lifesaver because, you don't need to store that much when you're doing the forward and backward pass. Just the LoRA weights plus the main model. You don't have to do a backward pass and store a second or third or fourth copy of all those weights, or optimizer state for all those weights, just for kind of these orange weights on the right. That saves you a lot of memory. With that, I'm actually going to pause and see if we have any more questions. That is all the content that I brought for you today. So, I'm happy to chat from here.